Hello everyone, my talk is about pentesting iPhone applications. It mainly focuses on the techniques and the tools that will help security testers while assessing the security of iPhone applications. This also covers existing mobile application threats and gives an overview on how hackers can steal information from your phone and what kind of information they can steal. These days, everyone uses smartphones, especially iPhone, and runs many applications on their devices. My presentation will make you understand what kind of information these mobile applications are storing on your device without your knowledge. It also guides you to protect information stored on your device. In short, my talk is going to be useful for everyone who has an iPhone or a smartphone. But who am I to tell you all this information? This is me. I was a developer for 1 year and then moved into information security. Since then, it's around 5 years working on web application hacking and reverse engineering, network hacking, Wi-Fi hacking, and mobile application hacking. My offline activities are contributing to OASP Hyderabad chapter and running a blog, securityland.wordpress.com. Before actually getting into pen testing of iPhone applications, I'm going to cover few basic things about iPhone. iPhone is one of the best innovations from Steve Jobs. Unfortunately, he is not with us anymore. However, his technology will be with us forever. Till March 2011, iPhone sales were more than 110 million. iPhone gives a platform for developers to develop two types of applications. One is web-based application, which uses JavaScript, CSS, and HTML5 technologies. And the another one is native iOS applications, which basically develop using Objective-C and Cocoa Touch API. Objective-C is an extension to C and very old. Because it is an old technology, it is vulnerable to buffer overflows and format string attacks. So Apple decided to add a Cocoa Touch API layer to Objective-C to get rid of all these vulnerabilities. iPhone only allows you to run applications which are signed by Apple. Apple created an app store to distribute these signed applications. App Store is a centralized mechanism to distribute the applications. People develop applications by following Apple developer review guidelines. Once the development is completed, they will send the application to Apple, and Apple will review it against the developer's guidelines, and if it feels everything is okay, then places the app in App Store. They have designed this App Store mainly to protect applications from piracy, and every application is reviewed by Apple, and most likely there won't be any malware. Apple has provided a platform, but why do people build iPhone applications? What would be the reason for it? It is because the world is moving from laptops to handheld devices like mobiles and tablets, and it's a new business, and enterprises want to make their services on mobiles so that it would reach out the users very quickly and easily. This is a good platform to launch new services. People who have new ideas, they can design a quick prototype on mobile and observe the users' responses. Mobile applications are quick to develop. Hardly one can write an application within a month. Because of the trend, there is an urgency for clients, and users also want them. And the final reason why people build applications is for fame and fortune. Take an example of Angry Birds. They have invested around $140,000 and in turn they have earned $70 million profits in 3 years. Now people have got some ideas and Apple has provided a platform. So they started developing applications for iPhone. If someone wants to develop an iPhone application, they have to use Xcode toolkit, and which only works in Mac OS. Once you develop the application in Xcode, you can use iOS simulator to test your application. But it is a simulator and misses a lot of flexibility and functionalities which are actually available on real devices. And iPhone only allows you to run applications which are signed by Apple. So in order to test your application on your own device, you have to subscribe for Apple's developer program by paying $100. Once you got the subscription, you need to submit your iPhone unique identifier UDID to Apple. After the submission of UDID, Apple creates a developer provisioning profile and gives it to you. Using that provisioning profile, you can install the application on your device. Because it is tied to the unique identifier, you cannot install it on other devices. If you want to test it over 100 devices, you have to register for ad hoc distribution In this distribution, Apple creates an ad hoc provisioning profile and allows you to install the application on 100 devices. Next one is in-house distribution, which is used by enterprises to distribute the applications internally to the employees. In case of in-house distribution, an administrator uses iPhone configuration utility to load the applications into employee's device. It's a tough task for administrators to do it on everyone's phone. To overcome this problem, they use over-the-air distribution. In over-the-air distribution, administrator places the application and provisioning profile on a server and distributes the link to the employees. Employees can directly browse the link from their devices and install the application. Main problem with this kind of distribution is if someone gets access to that link, they can download the application and install it. The final type of distribution is App Store distribution. If you want your application to be available for public, you can put your application in App Store. But remember that Apple only allows the applications which followed their review guidelines. So in general, applications are distributed as .ipa files. Now we know how to develop and how to distribute iPhone applications. But before actually distributing the applications, look for security weaknesses or loopholes in your application. Here comes the iPhone application pen testing. These are the areas that a penetration tester has to focus while looking for security loopholes in iPhone applications. Areas of focus include network communication, privacy issues, application data storage, reverse engineering, URL schemes, and push notifications. I'm going to explain these concepts in detail in my slides. One thing to understand is that there is an overlap between iPhone security and iPhone application security. As a penetration tester, first we should aware of all the security features and the loopholes in iOS. Okay, let's begin our hacking. To perform penetration testing, we need to install some tools on our device, and these tools are not approved by Apple. And iPhone does not allow you to install these tools because they are not approved by Apple. To run our own tools, we need to jailbreak the device. Jailbreaking gives full access to the device and allows to run code which is not signed by Apple. Once you have jailbroken the device, you can download the unsigned applications from Cydia. Cydia is a we can say parallel app store for unsigned applications. Jailbreak puts your phone at great risk to some security vulnerabilities because the device allows you to run unsigned applications. But jailbreaking makes penetration testing work easy. These are some of the famous jailbreak softwares: Panage, Red Snow, Snow Breeze, and Green Poison. Once you install Cydia, these are some of the applications you will require for pen testing. I have already installed these packages on my device. I will refer some of these tools in my slides. Cydia basically runs in three modes: user mode and hacker mode and developer mode. Choosing developer mode gives more flexibility and gives access to lots of tools. Once you install all the Cydia applications, you need to do SSH to the phone. iPhone does not give a terminal to see inside directories. To access the device terminal, we install a OpenSSH server on iPhone and a SSH client on a workstation like either Mac or Windows. Then we can connect to the SSH server on the device from client. This gives flexibility for us to browse the folders and execute commands on the phone. iPhone has two users by default. One is mobile and another one is root user. Using SSH, we log into the iPhone as a root user so that we get full access to the device. Default password for both the users is Alpine. Best practice is to change the default SSH password of your device, or else someone can do SSH to your phone when you are in Wi-Fi. If you won't change the default passwords, your phone may get affected to worms like iKey. If your phone and workstations are in Wi-Fi, you can directly SSH to the device by typing the IP address and username and password. If your phone and the workstations are not in Wi-Fi, you can still do SSH over USB wire with the help of iTunnel Mux software. This table shows some of the console and UI SSH clients for Windows and Mac OS. Hacking iPhone applications isn't all that different because Client-side applications or native iOS applications interact with the server-side components over network. So it involves network infrastructure hacking and web application hacking as well. And our client-side applications actually communicate to the server using some protocols, and these applications may use either of these communication mechanisms. One is clear text transmission over HTTP. Our apps may use encrypted transmission such as HTTPS, or they may use custom or proprietary protocols for actual communication to the server. So if we can capture the network traffic to the server, we can actually analyze it and find vulnerabilities. Capturing iPhone application traffic is little tricky, and we will see it in few minutes. Clear text transmission. It's 2011 and applications are still using clear text transmission protocols for network communication. In general, mobile applications are more prone to man-in-the-middle attacks because most people access them over Wi-Fi. An attacker who has access to the same Wi-Fi can run tools like Firesheep and capture all your HTTP traffic and hijack sessions. As HTTP applications are more vulnerable to man-in-the-middle attacks, applications which transmit sensitive data must use encrypted communication protocols like HTTPS. During pen testing, we can use the proxy settings provided by iPhone to capture the application traffic. Once you set these proxy settings, iPhone application route the traffic to the particular proxy which you have configured. These proxy settings on iPhone can be configured by navigating to Wi-Fi settings and setting up a manual proxy IP. Same proxy settings can also be used for HTTPS applications. In SSL communication, if we talk about browser-based applications, browsers automatically validates the server certificates. Whereas in native applications, the developers have to write a code which validate the server-side certificates. If developers does not write proper code, then the application will fail to validate the certificates. One common mistake that we see in iPhone application is use of allow any HTTPS certificate for host function call. If an application code contains this function, it indicates that the application can accept any certificate even if it is not issued by the original server. When an application fails to validate the server-side certificate, attacker can use any fake certificate and perform man-in-the-middle attacks on the users. User does not even get any certificate warning because the application accepts any certificate. While pen testing, check whether the application is validating the certificates properly or not. If the application is validating the certificate, it will display a certificate error when it receives an invalid cert and does not allow the user to use the application or proceed further when it receives an invalid certificate. This is similar to modern browsers behavior. To capture the SSL traffic during pen testing, you have to add your proxy CA certificate to the iPhone trusted certificate list. Then if your app receives an invalid certificate from proxy, it will not display any certificate error because we told our iPhone to trust the certificate. So it will not display any warning message. Once you do this, you can capture the traffic in your proxy. Same is applicable for other protocols which works on search. Now we will see a demo on how to add proxy CA certificate to our iPhone. In this demo, I am going to show you how to set up proxy settings and how to capture iPhone HTTP and HTTPS application traffic. In order to set up proxy settings, I am navigating to settings and Wi-Fi settings, and here you can find HTTP proxy options. So I clicked on manual, entered my local machine IP address and port number as 8080. Now onwards, if we access any website in your iPhone, it is going to route the traffic to your local machine. So I opened Safari and browse on my iPhone and entered some site. Now you can see Burp Proxy captured the request and displayed to us. Now I want to capture the traffic of Twitter application. So I opened Twitter application, entered my username and password and clicked on Save button. Now you can observe my Twitter application showed a certificate error because it received a certificate of Burp which is invalid. To capture the Twitter traffic, I have to install Portswigger root certificate on my device. To do that, I opened Firefox on my local machine and configured proxy settings and opened an HTTPS website. Because proxy is configured, your Firefox displays a certificate error message. So I clicked on view certificate and exported the birth root certificate, which is port figure CA. I renamed the certificate to .cer and stored on my desktop. Now I have to start a web server and host this file and browse the website on my phone. To do that, first I have to disable proxy settings on my iPhone. So I moved to proxy setting option and clicked on off. Now on my local machine I am using Python simple HTTP server and started a server on 8123 port. I navigated to Safari in my iPhone and entered IP address of my machine and port number as 8123. Now you can see it listed out all the files which are in desktop. So I clicked on port figure CA root certificate and it asked me to install the certificate. I installed the certificate. Now I am setting up proxy settings on my iPhone again. Now I opened Twitter application and entered username and password and clicked on save. Now you can observe burp suite which is running on local machine captured the Twitter traffic. Apart from clear text protocols and encrypted protocols, there are applications which uses custom or proprietary protocols for communication. To capture this network, download TCP/DOM on your device from Cydia, connect to the phone over SSH and run TCP/DOM command and capture the traffic. Write this traffic into a PCAP file and copy this PCAP file into your workstation and load it on your favorite network capture tool like Wireshark and use your protocols analyzing skills and identify the custom protocol. When applications are using custom protocols, you can use DNS spoofing attacks to perform man in the middle and capture the traffic. Apart from this, it would be possible to write applications which does not bother or give respect to iPhone proxy settings. In that case, even if it is an HTTP or HTTPS, you may fail to capture traffic in a regular proxy settings. So in that case, use DNS spoofing attacks to perform man in the middle attack and capture the traffic. Once you capture the traffic, it is a typical web application pen testing in which attacks are done on the application server. Now you can look for web application attacks like authentication, authorization attacks and session management attacks, weak ciphers and SQL injection attacks, and all the web application related attacks would be possible on iPhone applications as well. Privacy issues. Every iPhone has a unique device identifier. In short, we call it as UDID. UDID is burned into the device and we cannot change it. Apps may collect these unique identifiers to track the user's behavior. UDID, it is possible to observe the user browsing patterns and user specific information like Facebook profiles and his pictures, and it is possible to trace out the user's geolocation. This is really a big privacy concern, and more possible attacks are documented on Eric Schmidt iPhone application privacy issues. One such application which collected lots of UDIDs and tracked the user browsing patterns is OpenFind. It is a mobile social gaming network for iPhone. They collected device identifiers and linked it to Facebook profiles and geolocations and made it available to public without actually authentication. So if someone knows your UDID, they can actually go to this OpenFind URL and type the UDID and get your Facebook profile link and your geolocation. While pen testing, observe the network traffic, whether your application is collecting any UDIDs of your device, and if it collects, it's really a big privacy concern. Recently, Apple has announced that they are removing the API which gives access to the UDID. So in future, applications cannot collect UDID, which is a good news for us. Application data storage, one of the biggest security issues in mobile applications. Recent surveys conducted by Via Forensics revealed that 76% of mobile applications are storing information on the device, and 10% of them are storing plain text passwords on the device. Mobile applications are store information on device mainly for two purposes. One is for better performance and another reason is for offline access. In iPhone, these are the various places where your application can store data. Either it can store information in plist files, keychains, logs, screenshots and home directory. This is how a application directory structure looks like on iPhone. iPhone applications runs in a sandbox formerly called seed belt with mobile user privileges. Every iPhone has two users, root and mobile, and all the applications installed on the device which basically runs with mobile privileges. When you install an application, it gets a private area on the file system. These applications get stored under this directory where mobile applications, and every application gets a unique number under this applications directory. This table shows the typical application directory structure. So if you install an iPhone applications, this is how the directory structure looks like. Plist files, property list files. Generally applications use these property list files to store user preferences. Suppose if you are playing a game, plist may contain information like game level and your score and some other settings which you have made on that game. These plists are stored in documents preferences directory under application home directory. Plists contain key value pairs which are stored in binary format. This can be easily extracted or modified using plist editors or PL util tool. PL util tool can be downloaded from Cydia. Plists are designed to store user preferences, but the applications are storing clear text passwords and usernames and session information in this plist. So while pen testing, look for usernames and passwords in plist files. Also check whether your application takes any decision, any authentication or authorization decision based on the values which are stored in plist files. Suppose if you see a plist entry like admin equal to 0, change it to 1 and open the application. If the application is taking authorization decisions based on this plist entry, you may log into the application as an administrator. Best practice is to not to store any information on plist files. To demonstrate the plist storage, I am using WordPress iPhone application. WordPress older version is vulnerable and it stored username and password in clear text in plist files. WordPress is an open source, so I have downloaded the older source code and compiled using Xcode and loaded the application on my device. Because from App Store you cannot download the older software. Now I am logging into my WordPress blog using my username and my password. Once I logged into WordPress.com application, it shows my blog. I opened terminal and used a SSH client and connected to the device as a root user. After connecting to the device as a root user, I browsed to the applications folder where all the installed applications reside. These are all the applications which are on my device. So I searched for WordPress application using find command. From my application root directory, I navigated to library preferences directory. In preferences directory, I have noticed two plist files. One starts with com.apple, another starts with org.wordpress. org.wordpress.plist is more related to WordPress, so I used pl util tool and dumped the plist file. Now you can observe WordPress stored username and password in clear text in plist files. Keychain. This is another location where your application can store information. Keychain is a SQLite database for sensitive data storage. Keychain contains 4 tables: genp, inet, sut, keys, and Keychain is located in where Keychains folder. The file name for this Keychain is keychain2.db. Apple Keychain service is a library or API provided by Apple which can be used by developers to store sensitive information on the device. Instead of storing sensitive information in plain text configuration files or in plist files, they can leverage the Keychain services and instruct the operating system to store sensitive data securely on their behalf. Keychain is encrypted with hardware encryption key, and hardware encryption key is unique per device, and this key is not even accessible to the OS which is running on the device. So even if someone gets hold of this Keychain file, they cannot decrypt the content because it is encrypted with hardware encryption key. Keychain also restricts which applications can access the stored data. Each application on your device has a unique application identifier, also called as entitlements. The Keychain service restricts which data an application can access based on this application identifier. By default, application can only access data associated with their own application identifier. Later, Apple introduced Keychain groups. Now applications which belong to same group can share the Keychain items. On a jailbroken device, these restrictions can be bypassed by writing an application and make it as a member of all the application groups. This way, your application gets access to all other application Keychain items. I am going to show a demo on Keychain dumper tool, which was developed by GitHub guys. It dumps all the Keychain items and displayed on the screen. To demonstrate the Keychain dumper tool, I am using Shared Photo application. I have installed Shared Photo on my device and logged into the application using my username and password. Now I connected to the device using SSH as a root user and loaded Keychain dumper tool onto my device. Now I navigated to Keychain dumper tool. Dumper tool comes with a good readme file which lists out all the commands that we need to type in order to dump the keychain. The first command is going to list out all the application identifiers on your device. Using LDID command, we are making Keychain dumper as a member of all those groups. Now, when we type Keychain dumper command, it dumps all the Keychain items and displays it on the screen. You can observe WordPress stored clear test password in Keychain and Shared Photo also stored clear test password in Keychain. Information stored in Keychain is not secure anymore. While adding Keychain entries, applications can also set some attributes like make this item only available when the device is unlocked. In that case, Keychain entry is encrypted with user passcode as well. So if the Keychain entry is marked as when unlocked and user sets a passcode, it is secure. But unfortunately, applications cannot enforce the users to set a passcode. So storing information in Keychain is also not a secure way. Error logs. Many developers use logging functions like nslog for debugging purposes and troubleshooting purposes. Application may store sensitive information like usernames and passwords, request response sequences, and detailed error messages in the logs. So while pen testing, look into logs for sensitive information. These logs get stored in syslog file, which is located under private var log directory. To view the logs, you can download and install an App Store application called Console. Another way to grab the error logs is syncing with iTunes. Whenever you sync the iPhone with iTunes over USB, it automatically takes a backup of all your error logs, and these backed up logs get stored in these directories. If it is an Mac OS machine, they get stored under crash reporter directory, and if it is a Windows XP machine, they get stored under application data directory. Screenshots. Pressing iPhone home button shrinks your application with a nice effect. Your iPhone takes a screenshot of your application to provide such a nice effect. Suppose you are viewing your salary statement in your mobile application and press the home button. If the application is allowed to run in the background, it takes a snapshot of your page statement and stored in snapshot directory. These snapshots are stored under your application home directory. Solution for this default snapshot problem is applications should remove sensitive data or change the screen before the application is going to background. Another solution is instead of hiding or removing sensitive data, you can also prevent background running of your application by setting application does not run in background property in info.plist file. In this sample, you can observe that iPhone took a screenshot of bank details. Right side image is a snapshot captured after applying the fix. These images are copied from Sans website. You can see my acknowledgement on bottom of the slide. Home directory. Apart from plist files and keychains and logs, application may store information in home directory as well. So carefully observe all the files on your home directory. Applications can use custom encryption mechanisms while storing information on these files. Use reverse engineering techniques and identify the encryption key. Write your own tools to break the custom encryption. Reverse engineering. Applications which are distributed internally using in-house or ad hoc distribution are not encrypted. So straight away we can do reverse engineering of these applications. But applications which are downloaded from App Store are encrypted using Fair Play AES algorithm to protect from piracy. In order to reverse these applications, first you need to decrypt it. A lot of things were involved in decrypting iPhone applications. However, it became easy with Cydia tools like Craculus and installers. If you open Craculus, it will list out all the encrypted applications installed on the device. Click on your application and Craculus immediately decrypts it and stores a decrypted IPF file. Copy this IPF file and make it available to installers. Now, if you open installers, it will list out the IPF file which you have uploaded. Click on install and it will install the decrypted application. Once you have decrypted the application, you can use Hexres decompiler to reverse engineer the application. You can also attach runtime debugger like GDB and analyze the registers. Once you decompile the application, look for hard-coded passwords and encryption keys. If the applications are storing files using custom encryption, most likely that they store the encryption key in binary itself. In reverse engineering, you can also look for buffer overflow vulnerabilities. iOS 4.3 introduced ASLR, address space layout randomization support. Each time when we open an application, it gets loaded into a different memory location. Address space layout randomization restricts the exploitation of buffer overflows. Even if you find a buffer overflow vulnerability, you cannot exploit it because every time the binary gets loaded into a different memory location. iOS supports address space layout randomization. It does not mean all the applications by default use this feature. Applications must be compiled with position independent executable option for full support of ASLR. In iPhone applications, even if someone identifies the buffer overflow vulnerability and prepares an exploit, they cannot succeed because iPhone does not allow to run payloads or code which is not signed by Apple. For reverse engineering, I have downloaded Craculus and installers application on my device. Now I open Craculus. It listed out all the applications which I have downloaded from App Store and which are encrypted. I have clicked on Force Shared Sync application and it moved to cracking tab. Now I am connecting to the device over SSH using CyberDuck tool and copying the Force Shared Sync decrypted file to installers folder. And now on my device I opened installers. It listed out Force Shared Sync decrypted application. I clicked on it. It installs the decrypted application. URL schemes. This is a different name Apple has given for protocol handlers. In Windows, if you type mail to in your browser, it automatically opens up Outlook. In the same fashion, if you type mail to in your iPhone Safari browser, it opens the mail application. URL schemes provides browser to application interaction. To find out URL schemes supported by your application, Look at CF bundle URL schemes section in info.plist file. This info.plist file is available under application home directory. URL schemes also takes input parameters. Suppose if you supply email ID to mail to protocol handler in Windows, it opens the Outlook and fills the to section with the email ID which we have supplied. Similar fashion, iPhone URL schemes also takes input parameters and supplies these value to application. Large values supplied in the URL scheme parameters may crash the application as well. In this case, look at the error logs and identify the root cause. It may lead to buffer overflow attacks. URL scheme input parameters are hard-coded into binary. To view all the input parameters, decrypt your application and use strings command. Strings tool can be downloaded from Cydia. You can also look at this wiki page for URL schemes in different applications. This guy actually gathered different URL schemes in all the applications and maintaining a wiki. URL schemes takes input parameters and also provides interaction between browser and the application. So there is a possibility to perform remote attacks using URL schemes. Possible attack scenario is, suppose your application allows URL schemes to edit or delete data without user notification or permission. In that case, attacker can host a page with a URL scheme that deletes all the data from the application. One such real attack scenario happened is on Skype. Skype URL scheme takes the mobile number as input parameter and dials it without asking for user permission. This vulnerability was widely exploited and Skype fixed the vulnerability later. Push notifications. Application vendors use this service to push notifications to the user's device even when the application is in a frozen state. For example, an instance messenger application alerts the user when a new message is received even though the user is using another application. Device token is used for push notifications. Device token is different from UDID and unique for every iOS installation. How these push notifications works? Your vendor sends the notification to Apple and then Apple sends the notification to your device. So data transmitted in push notifications can read by Apple. So while pen testing, check whether your application is sending any important data in push notifications or not. Best practice is to not send any useful data in push notification because Apple also not guarantee the delivery of push notification. Also make sure that push notifications do not modify any application data. If it is allowed to modify the application data, it happens in the background and the user will not aware of it. Mobile threats. What are the major mobile threats? User may argue like all files on my device are encrypted and my phone is protected with passcode. Then what is the real security threat involved? The answer is mobile phones are easy to lose and easy to steal. Once the device is stolen, all the files on the device can be copied less than 10 minutes, even if the device is not jailbroken. This is possible with the help of boot RAM exploits. Currently, all the iDevices except iPad 2 are vulnerable to boot RAM exploits. Unlike workstations, data encryption on iPhone is only available after boot up. So using boot RAM exploits, we can load custom OS onto phone using ESP cable. This custom OS contains OpenSSH so that you can connect to the device directly over SSH and copy all the files. One thing to notice is even the user sets a passcode, iPhone does not use this passcode for encryption by default. Even if it uses for encrypting files or data, it can be cracked easily because a 4-digit passcode can be brute forced in 20 minutes. iPhone passcode validation is performed at two locations, one at Springboard level and another one at kernel level. iPhone locks the phone and introduces delays only if you try to perform a brute force attack at Springboard level. But if we perform a brute force attack at kernel level, Apple will not lock the phone and there won't be any delays and there won't be any data wipeout. So in this fashion, a 4-digit passcode can be brute forced within 20 minutes. So now we can say data stored on the device is only safe if the user sets a complex and lengthy passcode and all the applications encrypts the data using that passcode. But applications cannot enforce the user to set a passcode. So mobile security is still evolving and there is no standards yet to understand the risks. To know more about mobile risks, view Veracode and WOASP top 10 mobile application risks. This is the end of my presentation. These are some of the references which I have used to gather information. Thank you. You can email me if you have any questions. And my email ID is securitylen.wordpress@gmail.com.